California, did it hundreds of times in mountainous terrain.
Can you show like angles adding up to more than 180?
Yes, that's what I just said. Reciprocal zenith angles at 11 miles. Yes, did that. Brought it forth. Showed the simple addition. Work I did, not something I've copied out of a book. I'm sure NASA will put that right up on the VC or the TC.
So you're pretty content, like where you are, like, and when you go to bed at night and you wake up the next day, you're actually like 250,000 miles, like in space, different than when you went to bed.
Perfectly comfortable with that.
In like 5 different vectors.
Yep, because it comes down to a single net vector. Yes.
Have you ever tried moving something in 5 different vectors all at the same time and seeing what happens?
You know what? I deal with terrestrial land surveying. So the solar system is well understood, well studied, well modeled. We can send spacecraft to other planets and all this good shit. Yeah. So I'm perfectly happy with just staying on Earth. And Earth can do whatever the hell it wants because it's been doing it for 4 billion years.
Did you just say that Star Trek is real? Is that what I heard?
No, I did. Why would that's funny.
Yeah, you said spacecraft are flying to other planets. Where is that happening?
Space probes orbiting Jupiter, Saturn, Mars rovers. Yeah, spacecraft. Not manned, but spacecraft, yes.
Did you just say that Star Trek is real? Is that what I heard?
No. Space probes orbiting Jupiter, Saturn, Mars rovers. Yeah, spacecraft. Not manned, but spacecraft, yes.
Is there a flat Earth psychologist I can go to undo what I've already seen and already know now? Like, I want to believe it's a ball again. Is there somewhere I can go for help?
High school.
Because basically you're not cut out to be a flat Earth psychologist to bring people back to the globe, because you need to actually come up with some really damning evidence that we're on a globe.
Well, I just measure it. Okay, that's what I do. Been doing it for 35 years, done it in 11 different countries. So I got my own body of work. I find no fault with the publishings of the Ordnance Survey UK, the National Geodetic Survey, all of them. It fits. We have orbiting satellites, polar orbiting satellites that go directly across the North and South Pole every 45 minutes.
But even if like globe folks feel like they're trying to like readjust or like get people to see it different, but then they're interested in it at the same time, so they're kind of playing in the same waters, dipping their feet in the waters and hearing all the arguments.
I guess I can understand from their point why they do think it's interesting. I only knew what it was like for like a little bit though, to be like, what do these flat earthers think? Maybe like a couple hours, not even.
Or
No, the
maybe
mistake,
maybe a decade. Maybe a
the
decade or
mistake,
two.
mistake I made was when I first heard the questions from flat earthers. I thought they were asking questions they wanted answers for. Give them the answers, and they just say, "Oh no, you're wrong. This, that, and the other thing." I said, "Well, they already had the answers to the questions, so why did they bother even asking?" I thought they really wanted information and education in the skill and art of geodetic surveying. So I tried to respond, and then they shit all over me. So you're right.
You want to just talk about whether or not it's moving instead of whether or not it's flat?
Like I said, I just stick to the planet. And yes, the planet rotates. And yes, we do orbit the sun. That's as far as I need to go.
Well, how you determine such a thing would be where we would, you know, have a conversation, I guess. How do you determine that it's moving? Because you look at the sky? That's not,
Yeah, if we just met in the woods in the middle of nowhere and let's say the person you meet or whatever doesn't think the earth moves at all, and then you're saying it does, like what would you, and you're like, "Oh no, it definitely is." Like what would you be able to tell him to that convince you that it is in motion? I guess that's one way to think about it. Or like even like if there's like still tribal people like in South America that don't think the earth is in motion, and then if like you were to go there, what evidence would you have that you could just compel them? Let's say they're not, sort of modern day quote unquote flat earthers necessarily. They've just lived in the jungle. They don't have any reason to think the earth is in motion. Or maybe even like how there's like the pygmies in Africa? There's like these pygmy people that are still way out. I have a friend who went and visited them, and it took him like 2 weeks of travel, mostly walking through the jungle where there was no roads. Although he did get like lifted in a car to a certain part, but then they had to walk the rest of the way. It took them 2 weeks to get there. They were so outside of anything in the modern era, and yeah, so like how about like those people who really haven't been influenced at all by the Western world? So I don't know exactly what their cosmology is. I would assume it is a stationary planar kind of world. But if you were to go there and meet them, and then you were going to try to tell them, no, this whole thing is in motion, like what would you be able to provide them that would be compelling? Granted, let's say that they are just like normal people or whatever. They're not like quote unquote conspiracy theorists or any kind of other label that somebody might put on it.
A tribe in the middle of nowhere, the motion of the earth doesn't affect their ability to to live. So yeah, it doesn't matter to them either way. It wouldn't even matter. But if the discussion were, like why is there night? Yeah, earth rotates.
But if you go to them and I mean, don't you think they already have some idea of why there's night? Like they wouldn't just say they have no idea. So, and if they haven't already concluded that that's because the earth is in motion, then where do you go from there?
I'm not like I wouldn't be like a missionary trying to convert them into some geodetic, cosmological world, which has absolutely no benefit to their lifestyle or survival. Their subsistence farming, their, villagers. There would be no point to even delve into that subject. But if they ask why does night happen, I go, well, the Earth rotates, and that would be the end of the discussion.
What would you say to me if I told you that I purely use the laws of logic to, figure out that the Earth is flat? Like that's what logic tells you. Would you just say I'm wrong? Is that wrong to you?
You want to construct something that you're calling a working logic. There'd be no point in arguing how flawed your logic is.
No, I'm not talking about whether or not we're using someone's logic. I'm talking about using the classical laws of logic and just what that line of thinking does, for example, when I look and see Square Butte from 81 miles across the flat plain, I think that I'm looking straight at it. But, from your point of view, I'm looking over the curve and the light is, coming over the curve.
Well, to see the butte from 80 miles away, you have to be on a peak. So you're not down, at sea level seeing this. You're up on a
I
peak.
saw I saw Square Butte from Havre, Montana, and I was on the highway, and you can look out there. It's really flat. There isn't a peak to be on. There might be an anthill. I wasn't on top of somebody's house. Not that it would have helped. That was an observation that I made personally. So I like to use it. In the gazetteer that I originally read it in, it says that Square Butte is visible from 100 miles on a clear day. It's got 2,400 feet of prominence from most of the very flat surrounding plain. Anyway, to touch more on the logic thing, you don't feel like you're moving. You see the things in the sky moving. How far do you want to go? Laser interferometry, solving the Faraday paradox. What do you want? Have you ever even been introduced to the arguments about the lab frame, or do you just focus on the flat?
Danik, are you trying to say something or your mic's open?
Not at all.
What do you think about the lab frame when it comes to motion? You
Lab
want to pick
frame.
that up from what Angling said? You want to pick that up with him?
The inertial frame?
I want to hear about it, but I'm kind of more just listening right now. Yeah, he was talking about the lab frame I don't know, Angling, did you want to go through it with Zanick? Because I'd be curious to hear about it. Or what you were going to say about it.
Well, the stationary lab frame is what you use. It's the same concept in laser interferometry and in Newton's bucket. And when you apply it to the Faraday paradox, it makes it not a paradox. So I was kind of just turning that over in my mind a little bit. I should ask Zanick if he'd ever heard of it. Sure, you stepped into the physics a little bit, Zanick.
Oh, Faraday's Faraday's paradox, and the lab frame. It's hard to really make those two analogous, though. The lab frame in motion compared to motion to light. Give me an example where you have it's a problem, or there's it kind of strengthens your comparison.
So it's only, I've got the slides from my short presentation. I'll bring them up because it'll help me a lot. Give me a
Sure.
second.
In the chat.
Well, it said, I'm going to keep my picture scroll clean, unlike everybody else that has to scroll through a million things. But guess what? I'm just like everybody else.
Mhm.
I got that one, but it's not the one I'm looking for. There we go. Okay, that's the first simple one with the description of the Faraday paradox. What I might further to add to this is that, how when you see like a 3D diagram of what magnetic lines look like, and there's
Mhm.
intersecting lines that are perpendicular to each other. So if you think of like half of them as lateral and half of them as radial, it's only when the radial lines move in relation to the lab frame, or the conductor moves in relation to the lab frame in the presence of those radial lines, that there's charge, there's electromotive force. So the idea is like I was correlating that between the laser interferometer, because the laser interferometer tells you the same thing, that the ether is moving and the earth is stationary. And Faraday's paradox isn't a paradox if you know that it's only the radial lines and their relation to the lab frame that cause, electromotive force to happen.
Well, you break the lines of flux. The breaking of the lines of flux is what creates the EMF, the current to flow in the conductor. And
Yeah, but in Faraday's paradox, you'd be spinning the magnet, and the field lines would be connected to the magnet in that theory, but they're not. And it's not occupying any different space either, just like your tire, when you're spinning your tires, you're like, we use it as a metaphor for not going anywhere. You're not moving, so you're not, the wheel, if you will, isn't occupying any different space when you spin it, in that diagram of the Faraday paradox. Because it was assumed, that those lines or whatever, that they co-rotate with the magnet. I just think it an interesting thing, that, oh, okay, if you assume the lab frame and if only things move in relation to the lab frame, it's not a paradox. Okay, cool.
I have to remember in that scenario, in the Faraday paradox, why those lines of flux are not being broken when the conductor is not not rotating and the magnet
And to
is.
be fair, criticism from our own side that came from Man of Stone was that, the tolerances involved to be able to actually tell that there's absolutely no charge being conducted, is questionable,
Yeah.
So, I mean, for all the experiments that have been conducted, this is what it shows. But even Stone said that this, isn't a 100% type of deal. I guess I'd just like to throw that out there.
And with laser interferometry, you talking specifically about like the Sagnet effect, or are you like talking about?
No,
something
I'm
else?
sorry. I was talking about the Faraday paradox and like, when you spin a magnet against a conductor or whatever, and if you spin just the magnet, it doesn't show a
Oh
charge
no,
that there
yeah, I
might
get that.
actually be, the tolerances of that. I'm paraphrasing here, but the tolerances of those experiments he thought were questionable.
Right. But
So
when you
while I
mentioned
will use this argument,
but you also talked about the laser interferometry. So
yeah.
how do you draw the analog to that?
Oh, they're both referencing a lab frame that's stationary Earth. The fact that Earth isn't moving, they use that as a zero, if you will. The magnet isn't moving in relation to the lab frame, and the laser interferometer shows you that the ether is in motion. Static Earth, dynamic ether. Both static Earth in both scenarios. And then, like the same thing I said with Newton's bucket.
Well, we could talk about, yes. Okay, and give me the example now with Newton's bucket.
Oh, okay. So it's about as simple as this. If you're outside of the bucket and you're standing on the lab frame and you see the bucket rotating, you're going to predict that there will be a vortex in the center because you see the bucket rotating. But if you use relativistic terms, if you're standing on the bucket, you're in the bucket frame and the bucket's spinning, well, you won't experience the bucket spinning because you're attached to that frame. Therefore, you don't predict any vortex, but there would be a vortex. Simply just makes the wrong prediction, and that is it's super simplistic and crude when you think of it that way. Like, why would you even need to say something like that? And to that, I say exactly.
So you're saying in the rotating frame, where you feel the centrifugal force, you're not gonna predict the outward flow of the water?
I think I got the feeling he was saying that, and that's why I wanted
That
him to
centrifugal
explain it.
force was perfectly equal to the gravity that you already experience.
Well, that's silly. The gravity that you experienced before you were in that frame was down. The centrifugal force is
It's out.
outward, away
Yeah.
from the axis of the bucket. I mean, this is
Haven't you ever been
really,
to the fair? Haven't you ever been to the
of
fair and rode the
course.
gravitron?
Haven't
Of
you? I
course.
mean, I don't understand what you're talking about.
What happens if that structure
Yeah, down goes
breaks through?
sideways.
What if you break through? What if you break free from one of those places you're leaning up against, and suddenly there's a loose plank? Do you not fly out at a tangent to the direction of that rotation based on the surface?
I mean, you can't be serious. You really feel like when you're in that rotating amusement park ride, you don't feel an outward centrifugal force? Have you ever actually done that?
In one of those, like, I don't remember what space movie it
A
was, but they used
centrifuge.
they
A
used
big
the
centrifuge.
concept use the concept of a spinning wheel in space, and it's spinning at the exact right rate to where it creates the same gravity as Earth. You don't think you
Yes.
could do that?
And
But
what's
just
your
for our
point? I don't
theoretical
understand.
thought,
Are you missing something?
Yeah,
for our
you're saying
theoretical
they
thought
can't.
experimental purposes, you could absolutely be put into a tunnel or a chamber and experience the same exact gravity as Earth and
No, you
not know any
can't.
difference, but
You
yet there be a
can't.
Exactly.
vortex in there. You
And
could do
what?
that.
Actually,
And
you can't.
so,
And so if you were standing outside of that, then you would make the right prediction that there would be a vortex. And if you were inside of the tunnel, you'd make the wrong prediction.
that's ridiculous. When you're
No, that's
inside the tunnel,
not
you
true.
feel the force that makes the vortex. Are you kidding? I mean,
or,
come
or
on.
measure it, or measure it like you do on Earth. Isn't that why you weigh differently from the North Pole to the equator? Same principle.
Yeah, I
You
mean,
can
I
measure.
really don't get it. You're really suggesting you've actually ridden this ride, you've felt the outward centrifugal force, and yet you think if you were in that frame, you would not predict that water would be thrown outward.
You don't believe that you could replicate the exact same gravity going sideways and not know the difference?
You can't actually. You
Yeah,
can't
because of the
because
radial dependence, you mean?
you can still have the downward or the out. You can still have the weight on a scale on your feet if you're standing. Let's say it's going so fast that you're trying to replicate it. But if you have, if you're, I don't know if you're metric or English, but if you have 100 kilo on a scale going down, you still have 100 kilos going down as well. So there's a vector that it would never quite be right in your mind. The feel would not be correct. Can't ever
Well, I
replicate
think
this.
I think he's suggesting that we do go out into outer space. If you go into outer space, you can get rid of that, Earth's gravity field. You go into outer space, you don't get a vortex anymore. Now you just get water thrown out to the outer edges. But the vortex is because of the combination of the outward centrifugal force and the pre-existing downward gravitational force.
I don't think he's considering that. He's just kind of saying
I
that.
think you're right.
So, do you not agree that if I'm in my race car, which the videos of I had kind of a lucky keychain I used to have on there, when I used to take a 1.5 to 2G cornering turn, why didn't the keychain go directly sideways? That'd be like my G meter. But if I had a 1G lateral acceleration, the keychain would get a 45-degree angle. So that kind of addresses your point as being kind of illogical, does it not?
Yeah, and that same kind of thing explains why you get the parabolic vortex, because near the axis, the outward force is relatively small compared to the constant downward force. Your keychain doesn't get thrown out as much. Further away, it gets thrown out more. So you get the paraboloid shape. It
Exactly.
sounds like somebody misinterpreting some math and taking it more seriously than just your experience. You've been on this ride. I just don't understand how you can possibly think that the water wouldn't be thrown outward when you're in the frame, feeling the force that's doing that throwing outward.
Yeah, can you explain that for us? Because I'm confused as well. How it's not
Yeah,
possible.
is that what you expect to see when you stand next to a lake?
Pardon me?
Is that what you expect to see when you stand next to a lake? There's a
What are you
downward
saying
force,
exactly?
therefore the water in front of me should be vortexing.
Is this a spinning lake somehow? What are you talking about?
Yeah, I
I
think
mean,
he's
if you
talking
pull
about
the
us.
plug and then the water's moving downward, it'll create a vortex.
How is it moving
What are
downward?
you talking about?
Yeah, you have to. Are you smoking something? Because you're not really
You're
making any
you're
sense.
somehow you're correlating the fact that there's a downward force to the fact that water should be swirling, and I'm saying that
I'm not
a
saying water
lake
should
in
be
front of
swirling.
you won't be
What are you,
Oh
swirling.
what
man,
are you
okay.
talking about?
I can't take this.
Seriously.
No,
I
it's
think it's
super
fascinating
simple,
that
isn't
you
it?
can actually, you sound
Some of
like
the
you're
simplest
sound
stuff
mind
that I
and
learned
body,
from
but you're
Robert
making
Bennett.
like it's almost like you're talking gibberish. What do you mean? Can
Yeah,
you really,
that makes perfect.
you know,
Yeah, yeah.
you know how we think. Hopefully you could probably straw man our argument or steel man our argument. What are you actually saying? Make it so we understand what you're actually saying. And don't leave any details out. What do you mean by we're swirling into a vortex with this lake in front of me?
That's hilarious, dude. You guys,
No, I'm
it's
just
a
curious.
man in his bucket,
Can you
bro.
just tell me what you're saying? I don't know what you mean.
It's like rotate a bucket every 24 hours and see how much of a vortex you will get.
Are you trying to
How
explain
many?
what he's saying, or are you actually trying to add what he's saying?
No, I'm saying well, there's two vectors there. You have the outward as you spin, but you also have the gravity.
Right. So
So
we
there's a
know that the
combination.
outward, is 0.2% of our weight. So it's a small
Yeah,
factor. Okay. So we know
yeah, but
that the
that,
lake's not going to be affected by it because the water is only 0.2% less weight. Like you are 0.2% less weight when you're standing on the equator, standing there with respect to like with a plumb bob. You're just standing there next to a plumb bob, and your weight downward to the center of the Earth, the axis of rotation, is 100 kilograms, for example. That's it. It's going to be 0.2% less at the equator than it would be on the North Pole. But the weight is still close to that same 100 kilograms down to the center of axis of rotation. So where's this vortex? Can you answer that?
that was my point as well. We can measure this difference.
Where's their vortex?
Coriolis, maybe.
No, something has to move in the rotating frame for there to be Coriolis. That's by definition.
Oh yeah, of course. That was just a joke.
If
Basically.
you don't move, there's no Coriolis, right?
That's true.
You gotta start realizing these laws of the conservation laws. You go from an area of higher tangential momentum to a area of lower tangential momentum. It has to rectify
It's just
itself, and it does by this Coriolis effect.
and on top of that, we had Atvos effect as well, going
What effect?
east or west. Atvos.
What? Yodvos is a variant of Coriolis. We're not talking about Yodvos. We're talking mainly about just going from one position of tangential velocity to another point of tangential velocity. Right above latitudinally. So you go up a couple thousand miles. It has a lower tangential velocity versus where you left. That momentum has to go somewhere. Can't be destroyed. So it manifests itself in an eastward. If you're going north, it manifests itself in an eastward shift, a curved path to the east, even though you're flying straight.
So I still don't understand what his point, or the point he was trying to make about Newton's bucket. I mean, okay, two different reference frames, yes, but inside the bucket, you would be able to feel it or at least measure. That's not
That's what
what
Tim's saying. That's what Tim's saying. He's saying that you should be able, if you've ever been in one of these rides, he said, like, I agree. You feel it. Why would you feel it? How is it going to be different than you observing it from outside of the bucket? Well, outside you just see it spinning, and inside you feel the forces.
I just wanted to ask you, Zanick, like about Coriolis. Like, if you really do believe that a sniper accounts for it, like, how do you reconcile that with hot air balloons?
Well, there you go. So now your mistakes are now coming forth, which I like now. This is good because we can talk about it. So it's almost like the question that was just asked by the other gentleman about the Coriolis and not moving. The sniper accounts for Coriolis for Yodvos. East and west will be accommodated by them. They know that's and Yodvos is a different type of effect than the Coriolis we're talking about earlier. We were actually traveling from a position on the Earth at a higher tangential velocity, going to an area on the Earth northward that is at a lower tangential velocity. Hot air balloons are in the air that's actually attached to the Earth, roughly. So why would you? It's like the helicopter scenario we always heard for over 10 years now. But how does the helicopter just sit there and rotate when the Earth is, because the helicopter's in the air? and the air is roughly rotating with the Earth. In fact, on a calm day, it makes total sense because the air is not moving, so it's got to be moving at the same velocity as the tangential velocity as the Earth is. So why would a hot air balloon have any movement at all, deviating from its path as it travels, or hovering
Bullets
rather?
in the wind too.
Pardon me?
Bullets in the wind too.
Yeah, get rid of all the other forces. Yeah, there's no question there's other forces involved. You're going through air. Air is not always still; it's moving. So now the question is: are those forces going to exceed what the Coriolis effect or what the Iosvos effect? You could have air moving upward from the surface. But
That's just my
after you
question
remove all
is
those,
that
after you remove all those forces, what's left? And so the Coriolis is or Iosvos' effect is that
do
you
you
have to
really
consider.
think that snipers in combat think about this?
Depends how far the shot is. If it's
Why do the spotter bring why do the sniper bring a spotter?
That
you're
was
probably
totally
right because
irrelevant to the
a lot of
question.
them are just using the site. They're not calculating it out with a calculator. They know they're a mile away. If they're going to go for a mile shot, which is very unusual, but they can shot. What's the
That would
farthest
be,
shot that's on
All
record?
modern sniper teams use a ballistic computer. They have like a Kestrel ballistic
Well,
computer.
to answer your question, then, when we're on a gunboat and we're shooting a 16-inch diameter shell, 50 caliber across 25, 26 miles, Coriolis is in the friggin' instruction manual, and it's a chart that talks about exactly what you're contending. So why do you think they have that? If I'm shooting north, it's going to deviate 100 yards, 100 feet to the east. If I'm shooting south, going to the right as well. It's always going to the right, no matter which way you're shooting.
There's
By
an
how much?
interesting video of the USS New Jersey that's a museum ship, and you go into the firing solution room, and they said, and over here we have the firing solutions for ship to ship, which is only going 1,000 or 2,000 yards, and it's all mechanical. And they said over here on this side of the firing solution room is where we do the 25-mile from ship to land. And he states, he goes, this is where we calculate the curvature of the Earth and Coriolis for those firing solutions, because the hang time on those shells is over a minute and a half hang time to go those 25 miles.
Right.
We also did that in the computer in the M109, 155 millimeter. I used to be in a recon unit, and we were trained to guide artillery fire, and we were shown how Coriolis is in the system firing solution, as you said, in the
But
computer.
it's so dramatic in the big shells and big cannons, and we are presenting to this guy the evidence to that. The Navy does it, so we're answering his question. So are you in denial that they do that? That they know this shell, if they don't use Coriolis, will be off by 100 feet plus?
And like I said, the USS New Jersey, that firing computer and Coriolis effect and curvature effects, that still exists. And you can go look at that. And that's World War II. And the Germans, when they had their Paris gun, well, the maximum range you typically get from a 45-degree elevation angle. They found they can go a longer distance firing west by going to 50-degree because they got the longer hang time and the rotation of the Earth. Let the shell drop further west. Again, military big guns when you're dealing with these super hang times, as opposed to firing downrange, in line of sight of hundreds of yards.
It goes farther east when you shut it, right? Because the direction of spin.
As I recall, it was the Paris gun was shooting towards England, and they said they got increased range at 50-degree elevation because it gave them longer hang time.
Yeah, gave it longer hang time, yeah, because it's going against the spin of the Earth.
A good example, it was very practical, and a good example, well documented, because that was a big ass gun with a 100-mile range, whatever it is.
Yeah, today you when they do the firing solution, elevation of the target is tied into the Coriolis as well.
Right.
As you said, it depends a bit on the
Yeah,
flight
the
time,
full,
but also the elevation.
yeah, they have
Because
the
of
full
course,
chart.
the
The
lower
greatest-
elevation, the longer the flight time.
They have their whole chart. The most deviation going north or south, and almost zero deviation going east or west.
Oh,
But-
there's trig involved. Yeah.
But the
You know,
Yobos is
one-off.
it's always a
one-
factor. That is a different calculation.
My response to all this would be that, you know, one-offs or even a handful of instances would not be an indication necessarily of. I mean,
Okay,
it
the
would be an
Periscon.
indication of it, but it wouldn't be proof, is what I want to say. You'd
Okay,
need
the
to do
Periscon. Right, the German
controlled
Peris.
shots, you know, all the
They
time.
have a chart. It's chart.
Okay.
It's in the. It's been declassified in the Navy. I posted that information many times here. You think they just
And again,
made it up?
Yeah,
the
I remember
Periscon.
a guy telling me that he
The-
was
the-
on a Navy ship or whatever, and he said that they called it beyond the horizon targeting. So I don't
Well
doubt that they
beyond the
give these things
horizon.
great
Yeah.
names and all that, you know. And knowing what I know about trajectories of shooting out to about 1,000 yards, I can
Well,
only
that's nothing to do with it.
imagine how complicated it is to actually shoot that far and try to be accurate. Because there's like, unless you can test the wind out that far, the only way to be able to know what's going on is to be just lob things down there and see where it lands.
It's funny. They calculate. They have
Even
calm
even
days.
those guys.
They can have calm days. We have days where the water is a mirror, like in San Francisco Bay. If you were shooting from San Jose or Milpitas out to the Bay Bridge, about 30 miles, 40 miles, you would be off by a couple hundred feet without looking at Coriolis. No wind. Wind's not doing anything. It's freaking calm the whole way there.
Have you ever
Because
shot like
Coriolis is-
1,000
because
yards?
It's a real thing. And if you were on a gunboat or had a cannon there and wanted to make sure that was accurate, you'd plug in the direction you're shooting it, and then you put in your calculations about what angle you want to actually be with respect to the target.
and
believe
and
me,
you,
Have
you
you ever
mentioned
actually shot 1,000 yards?
what?
Pardon?
Yeah, but
Or like,
you mentioned one-offs. Like, okay, the German Periscon. Okay, I'll give you that. That's a one-off. But on the USS New Jersey, their firing solution computer, which is expressly called out for curvature and Coriolis, is on every large battleship. That those aren't one-offs, and not just the U.S. Navy. So that's not one-off. And as was pointed out, as was pointed out, firing tables and the formulae for those trajectories is published.
No, I understand that. Yeah, absolutely. I bet it is published, dude. And you're gonna, like I said, you're gonna hate what I'm gonna say. But unless we were the programmers to put that in there, how the hell would we know that that's actually what it's doing?
Are you
The
saying the
same
military?
song
The
and dance
military?
every time.
Are you saying the military installed all these analog computers, had all these firing tables, teach it in all the weapons schools, but you don't know if they're actually doing it? Is that what you're saying?
So you got the picture there. I got one. Let's see if you understand what these actually are saying. This talks about rotation, azimuth.
And that's another thing too. I actually
Correction
don't
for
even necessarily
azimuthal.
deny that this occurs, that
Correction
there's
to
this phenomenon that
listen.
happens. I can account for it with it,
This
you
is
know,
compensate for the
an ether
rotation of the
wind.
Earth. This is the Yovos ticket, and look at the deviations from pointing at the target, how it changes. Doesn't matter when you're talking about 2,000, 2,500 meters. So you already made that example, which was noted and not relevant because we're talking about things that are farther, where you can see what the effects are. And by the way, you start getting the long distance, 4,500 meters. Wow, look at that. You're talking 4 mils of change, but 0 mils at 1,600 or 4,800
I
north
guess
or south.
the real test would be, you know,
Well, no, but can you please address that? Because this is there.
I'm sorry, you know, go ahead.
You're at zero. You're 0 degrees latitude because there's a sheet for every latitude. This is at 0, and this is the azimuth of the towel in mils. What the deviations would be. So why is it at 4,500 meters? Why do we see this deviation go from 4 to 3.7 to 2.8 to 1.5 left, and then to 0, and then opposite as you continue this rotational azimuth? Can you explain that? Why they have this there? Why do you think they made this up, or it's just ignored, or it's just baloney?
Well, it's definitely not because the Earth is spinning. You know.
Well, of course it is. It's because the Earth is curved and it's spinning.
Yeah, I don't necessarily think so, man.
Well, you may not think so,
It's
but that's
funny. Yeah, funny how this ties into like things like focal pendulum, the large weather patterns north and south of the equator.
yeah. How do you have this precession of this Foucault pendulum that is never precessing at the equator, but you can predict your latitude anywhere else on the Earth with a Foucault pendulum based on its precession rate?
I heard people argue this again. These same old arguments,
Yeah,
time
but
and
you
time
can't.
again. We all
But it
know.
can't be. It's indisputable because you can go to France, and because you have a 33-hour rotation, this precession takes 33 hours, not 24. And at the North Pole, they say it's going to be 24, or South Pole 24. But we don't really have a Foucault pendulum there. But they've gotten pretty close to it by doing their experiments in that region. But these things are indisputable. They always work because of this effect, this rotational effect.
Yeah, I mean, as good as every university of some size on Earth has these, where
There's actually live
yeah, where the
video of these
students do these
pendulums
tests.
to watch. You can watch them spin right now. Probably go to France's university in France where they have that example in a museum or in a university, and you can see exactly what it's doing and see how it precesses based on its latitude.
I think this was debunked a long time ago, and I don't want to
Never
argue
debunked.
with you about it.
Ever. You've never
Debunked how?
debunked it ever. It's not it's not debunkable.
There's something
People try to
very
say it's true,
slight
and
that happens, but it sure as hell isn't because the Earth is spinning, and it's
Then what is
definitely.
it? But then what is it?
Then what is it? That's not even. That doesn't even make any sense, dude. It's the motion translated down from the sky is what it is.
No, that's not what's happening. You know,
No.
funny. What's that approach? Before he started getting a little more astute about what he was actually saying, he was actually saying, it's actually really funny. I remember quoting him on this, and he always backed out of it. And then he said, "I never said that." And then of course we had the recording. Why does the Foucault pendulum precess one rotation every 24 hours up at the North Pole or South Pole, and why does it not precess at all at the equator? Can you understand? Tell me about your downward. What did you say? What was your explanation to it? Downward forces from the universe. I don't know. What did you? Something kind of nonsensical.
And rotates
how
the
that
other
applies.
and precesses the other direction south of the equator.
It's
Yeah.
honestly been like 2 years since I really got into that, and what I'm remembering from it is that it's the same fictitious forces from the relativity nonsense.
It's not from relativity. What do you mean from relativity? You mean relative motion, or you're talking about Einsteinian?
I wish I had the
general
memory
stuff?
some of these other guys do. I go through and I learn it, but after a couple of years, it gets a little
Oh, I
foggy.
get it. Well,
So
just walk. Well, then
in
you can
the-
see. You can check your logic if you just walk me through what you're
in
saying.
relativity,
Why does
relativity,
the
there's
precession change direction below the equator, and it can predict your latitude there, and it also change directions as you go north, and you can detect your latitude in the northern hemisphere, and then only rotates in lockstep with the rotation of the Earth because, yeah, what it was saying, because the Earth is rotating underneath it. And
I
that's
kind of
what
lost it.
they said.
I was trying to remember how. Yeah. Because Whitsitt said it was
what you're
rotating.
saying is,
What?
So what you're saying, it's not the Earth rotating; it's something unknown which is causing the precession.
I could equally just as well account for it by saying it's the same motion translated down that's rotating sun, the moon, and the stars.
What?
It's actually accounted for. It's accounted for in relativity by what they
What do you
call
mean
the
relativity? You mean
fictitious
like
forces.
Einsteinian relativity? Relative motion or relativity? What are you talking about?
Yeah, relative motion. See, that's what I was saying. Like this was something I was a little bit better at about 2 years ago, but I kind of, I
Bad or
don't
yeah,
know,
you
the
were bad
argument
then, you're
obviously went
bad,
by the
you're worse
wayside
now.
a little bit.
Go back and get your ducks in a row, and
Oh,
we'll come back and
definitely.
talk about it because it's a fascinating subject. It's very it's cool. It's physics, basic physics. Talk about it in grade school. Why not learn? Dummy up on it. We'll go over it because there's nothing you can say that I can imagine that will dispute the this use of this tool to detect the rotation of the Earth because of the basic principle of objects swinging from a pivot point and creating a plane of oscillation and how that plane will rotate.
I kind of can't wait to explain all this again because maybe
Yeah,
there'll be
you should
some
do it.
new
It should be
ears that'll
motivated
hear
to
it
go
because
do it and
it's
try to
all
challenge it
old
again.
arguments.
And I'll get my old
Old
arguments as well that address these misunderstandings, and we'll have a little powwow about it
Yeah.
because it's if you understand why these things happen. And I wish I could remember what the what's it objection because it was actually classic, and I kept on saying, what are you talking about? I think I remember it's kind of very humorous.
All right, I apologize that I can't come up with anything better at the moment right now, but I guess I'll leave you with this. I remember Robert Bennett talking about when he was learning in his physics class many years ago, and then they started talking about fictitious forces, and he says, "Look how I'm paying good money for to learn about fictitious forces."
Okay, so therein lies the problem. So do you know what a fictitious force is? Do you know how it's defined in physics?
Yeah, they're basically like extra or outside of what is what is relativity, and it's ad hoc to make it work, I guess, in
No,
layman's
not at
terms.
all. So I remember Toons had mentioned to you, do you feel the force in the centrifuge when you're spinning around in that carnival ride? Do you feel yourself being pressed against the outer rim of this thing? That's because that's a fictitious force, but you still feel it. And why do you feel it? Still real, right? You still feel it.
I like to call it emergent force.
Well, fictitious force is fine. I mean, he doesn't like the word fictitious because it makes it sound like it's fake. It's just a word in physics that they use to describe, and I'll give you the answer. I'll give it to you right now. A fictitious force is a force without origin, and it's reference frame dependent. Now, just because it's reference frame dependent and doesn't have an origin, like a centrifugal force, all pseudo forces, it doesn't mean they're not real. They don't try to use it just to rectify things they don't understand or try to make the equations work out. No, it's actually real. All they're talking about is a description of where that force originates, where it comes from, and that it is reference frame dependent. It is dependent upon a reference frame.
It's a net. It's a net effect.
I think that's it.
It's a net effect.
The centrifuge is a really, really good example because if it's not spinning, there's no centrifugal force. As you start spinning it, the faster you spin it, the stronger those emergent forces are, or fictitious forces. It's not that difficult to understand.
But they still are reference frame dependent because if one of those planks that this thing was constructed with came loose, you'd fly out the backside, and your motion would be a tangent to the rotation in the direction that the tangential velocity of that outer rim. You'd fly out exactly at a tangent, straight as an arrow, not turning. The only thing holding you in is that plank that you're leaning up against that's been nailed or welded to the rest of the planks. Another example is turning in your car. If you're in a race car, we're taking a big turn at old Auto Club Speedway, and I'm going down the bank turned, and you're in my passenger seat, and your seatbelt's not attached. You're pressed against that door, and the door opens up. Where do you go? You go flying out. That is centrifugal
Yeah, that's
force.
where in Earth's orbit. we're in Earth's orbit where it's asymmetrical and it's not a perfect circle. There has
No,
to
in
be.
Earth orbit, where
That's
there's
where
no
that
forces involved.
linear
There's no
part of
forces in Earth orbit.
relativity comes in.
Free fall.
Where
It's complete free fall.
yeah,
Both the
free
Earth,
fall in a
Earth
straight line, like
a geodesic line, yes.
with no lined up with the North Pole, basically. Is that right?
We're talking about the Earth orbit around the Earth, or
Yeah. Which
Earth's
way
orbit
are we
around the
moving?
sun. Earth's orbit around the sun,
Yeah,
or something orbit around the Earth.
I don't know.
One more time. Earth's orbit around the sun, or something orbiting around the Earth. They're in free fall. Even though they're making a turn, it's a geodesic. That's a little more involved to talk about, because now we're talking about a curved path with respect to someone on the Earth, but a straight path with regards to the forces.
That's where relativity is just totally off in the weeds, man.
Oh. If you jump off a building, why are you in free fall? Yet we can measure you accelerating to the ground. That's a paradox. True paradox. Unless
for any acceleration, you need a continuous force acting on the object.
Right. Yet we can prove there's no forces acting on the object that gets dropped. But why is it accelerating? And they say that the ground is accelerating upward to the object. And that blows the flat earthers' mind, because they can't accept that sometimes acceleration is not a change in speed, but a change in direction. And the whole thing about the bending warping of space-time is a change of direction. That's why
It blows the flat earthers' mind. Yes, because the math is illogical, bro.
Logical where? So then what
Yes,
causes something? If it's illogical, you'd explain to me, why does something accelerate when I drop it off of a building? Why does it accelerate, but yet there's no forces acting on it?
Man, it's just like old as time itself, man.
Just give me whatever you're explaining. People would say it's bending, warping, in space-time, but what do you think it's due to?
What do I think that it's due? Like, really, you
Yeah.
really want my honest opinion,
Yeah,
man?
give me your, use your imagination. What do you think could cause something to accelerate without a force behind it?
Field pressure mediation.
What? What does that mean?
That's an
Field
effect, though, isn't
pressure
it?
mediation.
What is
So-
pressure mediation? When'd you
Field
throw
pressure
dielectric in while you're at
mediation.
it?
That's exactly how it's moving.
Why? How does pressure mediation work?
I mean, there are probably a lot of ways to illustrate it, man. I mean,
Oh, if there's any, if there's one, I'd like to hear it.
here's a good one for you. Do you know what a cymatic pattern is? Like the sand on the plate?
Yeah.
You know why the sand gathers in certain areas and doesn't in others?
But there are forces involved.
Correct.
Maybe field pressure mediation?
No.
Yeah,
That
you have
sounds
a
like
there are forces, vibration forces.
that sounds like an Uncle Fester response. Pressure
Certainly what's
mediation.
going on, mister.
Uncle Fester told you this, right?
It's just a malformed question, dude. How can you have an effect without a force? You can't.
It could be a really ultra low frequency sound wave.
And that is a force, pressure waves in the air.
No, dude, you don't have to grant them their claim that gravity is not a force. You don't have to grant that claim.
Oh no, I'm just he asked me literally what I thought gravity was, and I'm honestly giving him my answer, what I think it could be. I'm just saying I know.
He said
But it's
pressure mediation.
The
definitely
question was,
field
how do you have
pressure mediation.
acceleration? How do you have an acceleration without the force involved? That was the question.
Yeah, I don't have to grant that. Why would you think that there isn't a force behind an effect?
You can witness it. Drop an object. You can and put it in a container where you can actually measure these forces in there, and it's all in free fall. There's no forces acting on it. Yet we can measure it from a ground position. Measure that this object that's falling is actually accelerating. But yet inside there's no forces being measured. But yet we can measure it We can see it accelerating. That's either a
From a
paradox
ground.
or
You're
or
saying
there's a
that. Yeah,
reason.
you're saying you're just simply stating that there isn't a force because Einstein said that it wasn't a force, but it
No, you
most
can actually
definitely is a
measure it.
force.
You can measure it.
Yeah, yeah, you can measure the force. Absolutely,
No,
you can
you can
measure
measure
it.
there's not a force.
Nope, you can measure it because all you
You
need to
can't
do
measure
is wait for it to hit the
you can't
ground.
measure something that's not there.
We're
It's
always
there.
referencing
You
the
just
ground.
it's just
It's not
limited
there.
by your instrument is limited, right? So the accelerometer that you're using to measure it isn't going to be able to pick it up because it's limited in its engineering.
How would you suspect or how would you guess that you could actually develop some kind of tool to measure something that is not there?
No, you can measure it.
Give me a couple ideas of how that is possible. You're in free fall, and there's no difference between if you're in space floating, or you're being thrown off a building, other than air resistance drag. How do you
It's the thing is
rectify the fact that you can't measure this? You can't. There's nothing there to tell you that you're accelerating, yet you are.
I have the
no.
answer.
Well, see,
I
it's
have
a
the answer.
double. You're double speaking. You're saying it's not accelerating, but it is accelerating. So
It's
which is it? Is
inertial.
it accelerating or not? Because if mass is accelerating, there has to be a force behind that
That's
acceleration.
why it's a paradox.
Logic itself necessitates
No, but that's the
for
paradox.
every. Hold on, dude. Hold on, bro. For every effect, right? There's a necessary antecedent. It's actually called a cause, right? So
Yes,
every effect is the
Newtonian physics.
cause. The cause is synonymous with a force,
Okay,
right?
you're
You
stuck
can't
in
have
Newtonian
an
physics.
effect without a
Let me know when
force.
you're done.
I'm done.
I keep on. Okay, so in Newtonian physics, you'd be right. That's why for years, and we still to this day still can apply pseudo forces in these scenarios and get correct answers, even with the knowledge of Einsteinian physics. These all can be expressed in terms of each other as well. But no, this object that is falling is accelerating. You can actually visibly see and measure this second derivative of distance with respect to time, i.e. acceleration, can be measured. Yet inside that box, these objects are all free falling and there's no forces acting on them. So you have to explain to me what kind of tool could you measure this required antecedent, as you said, of a force when there is measurements of no forces being involved in these falling objects. But we see
Is
them
that
Just
due
accelerating.
to the forces sort of equalize?
Just because you can't pick up, right, the centrifugal force because there aren't any centrifugal forces acting upon the object because the object is basically at an equilibrium, right? It's reached a point where the accelerometer isn't going to pick it up, right? Because of the
right.
downward vector. Because of the downward vector.
No, there's
So
no vector.
it's like
there's no vector.
it's like
There's no force.
it's like
It's
hold
in
on,
free
dude.
fall. It's inertial. It is
Oh,
stated
shit.
to be inertial. It is inertial. It is not accelerating nor turning.
It is accelerating. We can perceive it
No, it's not.
accelerating.
You measure it to not be accelerating or turning.
It is accelerating at 9 meters per second squared, dude. It's
Yes, but
most
there's no
definitely
forces acting on
accelerating
it.
towards the
There's no
ground.
forces. It's
So how is it
inertial.
accelerating? So how is it accelerating?
Well, because there's one theory that says it's passing through the warping and bending of space time. Its path is actually turning, even though its speed is not. Its path.
So there is a force.
Is going forward, but with respect to the Earth, that space time is curved and it's curving toward the center of the Earth.
Yeah. So there is a force.
No, there's no. I just got to saying, well, there isn't a force. There is
Okay. So
absolutely no
why do you
force involved.
have? So why is the kinetic potential or the kinetic energy multiplied?
Why does it have kinetic energy? Why does it have potential energy when it's dropped off a building?
Not just why. Why is it multiplied? If there's no force behind the object, how come it's being multiplied? The kinetic
Why
force.
is it accelerating? Why is it accelerating? Is what you're saying?
Not just accelerating, the kinetic potential is multiplied as it accelerates, showing you that there most definitely is a force.
It's the second derivative of distance with respect to time.
Force equals mass times acceleration, right? Not only do we pick up acceleration, we also pick up the kinetic potential being multiplied. And then you want to deny not only that the mass is accelerating, that the force itself is being multiplied, and then say that there's no force acting upon it.
Well,
kinetic energy is just
you're mixing up terms a little bit. Go ahead. Sorry.
Yeah. No, I mean, kinetic energy is how fast an object is moving and the mass of it.
With respect to the ground.
Yeah, or a surface of some sort.
Right. And so, yes, we know that it's accelerating when we look at it, and we can calculate by the moment it's dropped what that kinetic energy, this potential energy, which is when it's before it's dropped, is a potential energy, and it's always with respect to the ground. That's a given. And we drop it, and suddenly we know that object will release and exchange potential energy with kinetic energy until it hits, and it'll just the opposite will occur when it hits. That's a part of the paradox. Yeah, we are accelerating. We are increasing kinetic energy with respect to the ground. But why? Because the gravity is a pseudo force.
Oh
Just
my
like
God, dude. See, the
that is
biggest
the reason.
indicator, the biggest indicator, right, that we're dealing with an actual force isn't just the fact that it's accelerating. That's one indicator. The second indicator is that the mass itself, right, when it's accelerating, the force is being multiplied, right? So when it hits the ground, the higher that you drop the object, the harder it's going to hit the ground. So you have two indicators that we can empirically observe with our senses and empirically measure with accurate detection, and we can measure the force being multiplied. Yet, you're telling me that I had to ignore both those indicators
No,
and
you
say
got
that
it
there's no
backward.
force acting upon it.
Well, you actually have it backward. You have the right idea, but here's going to blow your mind. I mean, you've probably heard this before. You're actually right. There's an acceleration, but guess what? It's not the object, because I told you already it's inertial. The ground is accelerating up to the object. That's why you
No,
have the
it's
impact.
not.
It's accelerating
The
upward.
ground.
It's accelerating upward at
He's a
9.8
rising
meters per
earther.
second squared. Yes, it is.
Jesus Christ.
You
See
can
now
prove
they
that
have
by
to
standing on a
resort to.
scale. Hold
They
on,
have
hold
to
on.
be.
I let you
All right.
speak. I didn't say a fucking word.
I'm sorry.
So
I'm
stop.
sorry. Go ahead. Go ahead.
So you can stand on a scale and you can measure your acceleration. The acceleration of the ground. The ground is coming up at 9.8 meters per second squared. That's why you have a register. You know you're not moving. You can see it. But why is the ground going up? That's the normal force. Your pseudo force is going down because you are inertial if you're dropped. But when you're standing on the scale, there's a proper force pushing up on you. It's accelerating upward. The ground is accelerating upward. There's
No,
your
it's
answer.
definitely not accelerating upwards.
Why not?
I don't know why you would abandon reason and rationale just to keep your model afloat. It's kind of funny, dude. It's known as belief perseverance.
No, it's
you have to resort to rational understandings of things.
irrational. How is it irrational? Because
It's the
Because
sunken
you have-
cost. It's the sunken cost. Zanick has put so much into it. You can't turn back now.
all I have to
I'm
do,
fully committed. I can't change
Zanick,
my mind
all I
now.
have to do to demonstrate that you're wrong
I'm
is
too
very
vested.
simple.
I'm too
You
vested in this.
get a scale, right? You get a scale. You put it up against the wall and you lean on it, right? Just by simply leaning on it, or even push up against it with your arm and keep steady pressure on the scale. You're not moving. The scale's not moving. But guess what? It
Two proper
registers.
forces.
It registers a force by
Two
simply
proper
leaning
forces,
on it
yes.
or pushing it on it. Now, the scale itself isn't accelerating towards you. Instead, you are the one accelerating towards the scale. You are the one
You're not
pressing against
accelerating.
the scale,
No.
causing it to register a weight.
No.
It's no different
You're
than when
almost
you're
at it there.
standing on the scale, right? When the scale is horizontal on the surface of the ground, when you stand on the scale, your body itself is pressing down, right? You are accelerating down, causing the scale to register. Why would the Earth be pushing up? Why would the Earth be accelerating
I'm
up?
trying to
Why
tell
would you
you, you're
resort
not
to that
listening.
irrational stance? Go
I'll
ahead.
give you the answer. I'll give you the answer right here. Pushing against the wall, if the wall was to give way, it would then accelerate. Right now, you have two forces you have zero net force. You're leaning against the wall's leaning against you, pushing against you. Just like Newton says, two proper forces, no argument. However, when you're standing on a scale, a whole different paradigm is set up now. Because if that floor gave way, you would then accelerate at 9.8 meters per second downward to the lower floors, but you would be in free fall while you're doing it. not accelerating. No force is acting on you. The other scenario against the wall, you'd have to be continuing to push that wall. You'd have to continue to add force. You have to put a rocket engine on it to continue to accelerate. You would feel it. You'd feel G-forces the entire time you're accelerating laterally. You don't feel any G-forces when you're dropped. Don't you see the difference? Think about that. You already talked about it against the wall. Now you're talking about the scale. And you said why, and I'm trying to let you conceptualize what's going on. The wall scenario, if I'm going to continue to accelerate laterally like you're in a 911 turbo and you're going to accelerate to 60 miles an hour in 3 seconds, you have 1G pushing you in your seat. You feel that. But I drop you, same acceleration, you feel nothing. You see? So something has to give here. You have to understand there's something that either a paradox or there's an explanation. The explanation, as modern science accepts, is that the Earth is accelerating upward, that the free fall, you're inertial, and it's happening because space-time is bent and it's bending down to the center of the Earth. There you go. Now your mind has been blown. I love your passion. I love your.
I gotta get back,
fight,
dude. I gotta
but-
get back. I'm at another delivery, but listen, we'll continue with that.
All right, Bubba. Always a pleasure.
No, the resolution is that there just is a force that causes the falling, and
Why don't you feel it?
accelerometer just can't pick it up because it's a limited device, because the sensors are moving at the same speed as they're all free falling together, because everything free falls together. So that's what resolves it. You don't need to have the Earth moving up. You just do have a force when it's falling. That's what gravity is.
Well, how can we feel it if you're laterally traveling, we feel it, you're pressed into your seat accelerating, but when we're dropped out of a building, you feel like nothing. Why does those two things, which are exactly the same acceleration, why do they feel so different? Are we also unable to measure the force? But we can. We know the difference. We can say, hey, laterally I felt this friggin', my face was pushing backward, my mommy, my pigtails are too tight. But when I dropped off a building, everything's relaxed and everything's floating. Things in my stomach are floating, I'm floating, my hair is floating. Water, saliva in my mouth is floating. Everything's floating.
Yeah, it's because
But
the XY axis is different than the XZ axis. Vertical is different than horizontal. Well, there's only a free fall in the vertical matrix. You don't free fall sideways. You free fall vertically.
But if I wanted to show you the acceleration laterally, we feel it. When we do the acceleration vertically, we don't feel it.
When you're
You
dropping,
said it was
yeah.
an instrument.
Yeah, because in order to like horizontally move, you always have to push in some way. But to free fall, you just have to let go, and everything free falls together. So the accelerometer is free falling. The sensors in the accelerometer that would normally be pushing against each other when you go horizontal are just both free falling together. That's why it's not registering something. It doesn't mean that there's nothing going on. There's not an acceleration going on. There is. It's just not able to pick it up. But you're using that assumption that there isn't one to then have to say the Earth is moving up, which just leads to a whole faulty conclusion or faulty outcome.
Well, how come we don't feel anything? Like you said, maybe the sensors can't pick it up because everything's falling in unison, you said. But why can't we feel any acceleration? We can't feel acceleration. We can only see it.
You do. No, we do. Have you ever
No,
jumped
you
off
won't.
have you ever gone cliff jumping?
Of course. Who do you think you're talking to?
What's the tallest you jumped off? I did 100 feet once.
I've been 75 feet a few times, but yeah.
I think we
Probably
measured
didn't
it was like 90, 95 or so, like almost 100. Dude,
Dude,
it is.
90, dude, are you crazy?
Yes, it was crazy, and I was crazy to do it. We
It hurts
filmed it
your
too.
feet. We had to jump.
Dude.
We had to jump even at 75 feet. Where we weren't diving. We were just doing backflips. But when you land, man, your feet. First time we did it, man, your feet were hurt for like the whole day. So we started
Oh,
jumping
yeah.
we used to jump with flops on.
You
Now these
gotta
days they're
wear,
doing people doing belly flops at that height now. I don't know how they do that. I've always wanted to try it, but I figured if I did it, I'd probably get knocked out and die.
no, it's not a belly flop. It's called like death diving.
Right.
It's not really a belly flop. It's
Well,
like
no,
the
you get
opposite of a
your
belly
feet
flop.
and your hands together in front of you, which break the surface tension. But I can't
Yeah, they
imagine actually
say-
doing that.
I know, me neither. But they say it's actually better. Because, dude, when you like doing like 100 feet like that, or like you said, 75, because there's one area of cliffs. There's like several. There's like the 100. There's a 70, 50. You know, there's several of them, and Dude, I couldn't imagine doing that death diving thing, but they say it actually is a better impact because, yeah, when you do it like just feet down, like remember those aqua socks back in the 90s? Like we had to wear
Oh,
like
yeah.
aqua socks. Like you got to wear something because
Yeah.
it will smack the bottom of your feet.
But
It's
don't you
intense.
think like I guess your hands and your feet because they're kind of pointed now, and it's not a flat surface. Break up the water. Then by the time your face hits it, it's already kind of turbulent. I guess that's the theory. I kind of believe it, but I don't know if I'd risk my face on that concept. I'd end up doing it and probably end up getting knocked out. To say at my age now, I'm just not. I do other things that are pretty death defying, but not. I can't get myself to do that. I want to, but I just can't do it.
Yeah, but dude, they do it insanely where they jump off massive and they're flipping and turning, and then right at the end they just go into that
Boom.
pose.
Yeah, I know. It's
Yeah.
crazy. It's insane.
It must be better. Like I've never tried that because that's kind of a newer thing.
I wish that would have been a thing back when I was younger because I would have definitely been doing that. That would have been fun.
Dude, you really want to do that though? You want to be 100 feet
No,
or whatever, 75,
not 100 feet.
whirling towards the ground and then go into that like, basically it's like a, what is that kind of position? Yeah, like, you know, if you were crawling, basically.
Pike, like a pike position.
It's like crawling, but your feet are pointed down, or like a
Pike. Your feet and your hands are in front of you, so that they're not flat though. And then when they hit, they kind of break up. They kind of like a knife into the water, get the water moving, and then it becomes just. By the time your face hits it, it's all kind of just bubbles.
I guess so. I know it's like a downward dog in yoga, downward dog pose.
Exactly. Yeah.
But anyways, but the thing is, dude, when you cliff jump, you can feel the acceleration. I mean, when you first launch off, you know, let's say you run, because I like to do it when you're like a running jump. So you do a running jump and you go run, and you do your last leg, you know, extension off the rock, and now you're falling. And at the beginning, it's like, you know what I mean? It starts slow, but by the time you hit the water, you are cooking. You completely feel all the acceleration and the dropping. You feel yourself going from slower, like when you're running and you take that like you're not really falling very quickly yet because you're going very horizontally. So you're kind of, you know what I mean? Like you got all that momentum. So at the beginning, you kind of feel like you're just almost like you're going straight, but then all of a sudden, you know, you start falling down, and then it accelerates as you hit the water. By the time you hit the water, you're going real fast towards, you know, terminal velocity or whatever, but you're not going to reach that just from cliff jumping.
No, you're not going that fast, but you're airborne by. I mean, you just do the drop calculation. You're probably airborne for 100 feet. That's substantial. You probably like three seconds or something.
I only did that 100 feet one, like I think once actually, because I did the 75 and the 60s at that particular site. I only did that tall one once, and yeah, it was crazy.
Everybody's there watching. You lose your fear. Everyone's doing it, so you're doing it too. And so if you're by yourself, say, "Hey, jump up this cliff," and no one's watching, you're like, maybe I'll pass. That's a long way up, 100 feet. That's really high. Especially if you're doing aerials, and I love watching these guys that can just jump off of a rock and just do full twisting, you know, front flip, pike, another twist, and then boom, in a dive or even the feet.
Yeah. So why would you say there's not acceleration when you can feel it just doing cliff jumping?
What you're feeling is a change, a change of having weight to being weightless. So yeah, that you definitely feel that, and that to you becomes this. You've learned to realize that it's acceleration because you know what the consequence is. You have to be accelerating because when you hit the ground, you know you're freaking going, you know, 70, 80 miles an hour when you make the contact with the ground.
You can even hear it in your ears, you know, like the wind in your ears. At the beginning, it's like, shh, you know, by the time.
You're definitely mocking through the air. I mean, there's definitely drag and there's definitely going through the air. No question about it.
That's the acceleration. It's downward. If you want to call it a force, you can, gravity, etc.
Oh, you're absolutely accelerating through the air. There's no question about it. You can feel it, measure it. You can take an anemometer in your hand and measure exactly the airspeed at which you hit the ground. Airplanes fly all the time, and they crash all the time, and we know the speed of their impacts, and their airspeed indicator will definitely tell you what you're hitting the ground at. That's not the point. The point is, are you in free fall or not? Are you having any forces acting on you besides the drag? which,
Well, it just
which
depends
slows
on
you
whether
down
you
a little
want to
bit.
define it as a force or not. But I mean, weight, what you want to call gravity. I mean, it just depends on what you define it as. But you're definitely accelerating down towards the ground. I mean, there's just no scenario that the ground is coming up to meet you. There's just none. There's only like, in my view, kind of like just like a like a mind exercise way that you could think about it in that way. But it's not real physics that the Earth is moving, up towards you. You're just accelerating towards the water. Why would it be anything different? Zanick's like,
you're
well, when you put it like that.
no, I mean, I don't argue with you about it because I know we both are looking at it from two different perspectives. But I just plugged in your 100-foot, 30-meter cliff. You're hitting it 55 miles an hour, and I said 3 seconds. It's 2.5 seconds after jumping. Because mine was like 2 seconds, I think, by the time I hit the water. Yours like 2.5, 3 seconds.
It's like 0 to
55
60
miles
in
an
a
hour.
Porsche.
What's that?
That's like 0 to 60 in a Porsche.
Yeah, that's what exactly. That's why, yeah. It's 55 miles an hour and 2.5, so probably 60 miles an hour and close to 3. That's why they say if you were going to accelerate 0 to 60 in 3.5 seconds or something, or so 3.2, 3.4, that's like the same force of gravity pushing you in your seat. But you feel that. You feel it. You don't feel it jumping.
I'm
You
sure
just
this is
feel kind of weightless.
I'm sure this has probably been asked before, but how is the Earth accelerating upwards on a globe everywhere?
Because the acceleration is not the change in speed, which is a change of velocity, which is acceleration. It's a change of direction, because direction is a component of velocity. It's a vector, the direction and a speed. And so the direction is changing, and that's the acceleration. So there's the answer. The ground doesn't have to be moving upward. You just have to be having a curved path based on the bending warping of space-time.
I can. Also, everybody's muted. Notice that. Very astute here.
Give us the latest updates in AI news, Snax. What's happening in what's the new frontier?
Oh no, is there stuff happening? I don't keep up on that
You're
much.
you're our AI correspondent guy.
I really don't have anything. Maybe there's stuff that happened. Every day there's a lot that's going on. AI correspondent out.
Oh well, okay. Thanks for that very thorough, detailed manuscript of.
I don't. In the real world, I've just been battling mine today. So
battling mind or
like no battling
mine as in your AI.
Yeah,
okay.
just trying to get it to do a thing that I've been sort of putting off, but then I'm like, we'll see if this code works. But then I'm like, am I even doing this shit? Like it's I'm not really doing much. I think I should be doing it a different way, like trying to talk to it for doing these heavy things. I should be using like Visual Studio or like VS Code or something like that, and then using like the Copilot. It would seem to be an easier environment for it to do programming. If I'm asking it to do programming within chat context, then I must be making it harder for myself and self.
I don't know. I barely understand it. I'm not tracking.
Like you're like you're trying to do something complicated with your robot, trying to have it create something like a program or whatever. Could be a website, could be anything.
Well, what is it? Have you seen Eggshell's new
he should
interface?
be using VS Code too. Yeah, he's fucking around with like the Claude code as the CLI, but he should be using something that's going to create the program like that's built for doing that, built for assembling a program rather than you like hoping it's going to one shot it. It's going to have to use the server that you're talking to like sort of scaffold all of like code building. It's just easier to have it like natively going on the computer, then you can see it and then it can access all that stuff. It's not held in like
what are you talking about?
Ghost memory. What am I talking about?
What do you mean? What's he doing? What is he doing? You said what he's doing. I don't know. Like
what
he's got
he's doing complicated
he's got a new
shit.
UI.
His UI,
have you seen the Jarvis thing?
Yeah. He had like Claude write that for him, right? So what is Claude writing that in? It's probably like JavaScript, I guess, the front end piece there. It does all the wiring, the routing, and all that stuff. But watch him try to change it. He's going to have Claude Code is going to have to read the whole thing again to make changes, unless it like has unless some very interesting handling is going on. It means that every time
so how do
you do redevelopment, you're doing it the hard way because you have to like kind of reinterpret what you've already made and then make from there. So it's better to just have that project file saved and then not talking to the AI through like what you would use to just chat to it with, but like using it as like Copilot, like which is a plugin for VS Code that you can just pipe an LLM through. So you could pipe the Claude code into Copilot and now you're working within VS Code, which is like a whole coding studio. That's the way I think.
I have no idea.
It should be done.
It's all hocus pocus.
What do you?
I kind of principally understand where you're coming from. Is like when it has to. So he's built out his Jarvis interface, right? From what I see that he does, essentially, like he can take a screenshot of a certain section of that window and say, "Pardon."
Do you like the color he chose? It seems a little bit dark blue for me. Would you pick a different color? Maybe that's the biggest problem.
I don't know, bro. But he screenshots it and he says, "I want a button down here that does X," and that's how he's sort of doing it.
Right. I was doing something like that like 2 weeks ago with the little music program that I made, and there's a button, and I'm like, hey man, I want to hit this button, and it's gonna play patterns just like this one incredible bass player, and I made that button, and I was like, this is the best fucking button I ever made, man. I just hit it once, and it just makes that thing happen, and buttons are fucking awesome.
So what's this idea though that you're saying that like it has to reread the entire code and then work out where it needs to place the button inside the code? Is that what you're implying?
Kind of like it needs Rome doesn't get built in a day. You're not going to build a awesome app in a day. It's not going to be all finished. So just in the process of it, like like have a strategy for how you build the app, like how you save the things, like make the big piece of what the app is doing first, and then like kind of add feature sets to it, but like let it know that that's what's going on. Like we're building another feature for this thing, and then it's not like, oh wait, what is this project again, man? Like let me read the entire thing to my memory and use most of your tokens, and so
this is what I want to start doing.
That's what we're trying to do. Just like, yeah, like computationally you can get it done, but it's like you will definitely pay more tokens if you do it certain way. And then you might not be able to finish because you'll hit the token wall, and you'll be like, oh, I'll just get another account. And you're like, I'm just like, $200. That's not a big deal. And that, yeah, I've seen people like kind of have to. That's the only way. You got to feed the beast. And that's all I got to say about that. That's my Forrest Gump close when I talk too long. This is this one thing I've been trying to do for, I think it's been 16 hours, and I just like say it just hangs up, and it's like I'm like, okay, and then it's gonna keep trying, like this done. Very complicated what I've had to do. Probably the wrong way. I probably
no.
hours. I'm gonna have to redo the whole pipeline for how this understanding of music is supposed to go on, which is the initial challenge that that started me out on this shit. Yeah. How do we get it to listen to music?
I don't understand that. I mean, my understanding is that it just listens to music. So, I mean, are you saying like listening to music is different to listening to an audio clip or something?
Yes.
Okay, so this is where you sort of like when you say listening to music, you're referring to sort of that the intonation that the music is like, high pitched or maybe that's a bad, like, it has a certain melody to it, which is either sort of like gleeful or it can be sort of what's the other terminology?
Just mood.
Impending doom. Yeah.
It could be lots of things like that. Yeah. So it like, and just like understanding like how the chords might be, like they have kind of qualities to them. If they're minor or major, sometimes you can just infer what it's going to sort of sound like, but sometimes you can't. But there's a whole program that kind of has been made to sort of get these reads on how the music, what the vibe is, So there's that component. There's the real technical stuff, like all the chords, notes, percussion, instruments, textures, timbres, all those things, right? Like it means something different if there's like, like a whole string section backing up a song. It can really make it different.
Do you expect this to be sort of how to describe this? Like useful for the human being to communicate with the robot, or it's more a case of actually letting how can you sort of enrich the experience from the human being's point of view? So
like an LLM really does. It has like, it can tell you what it thinks a song is, and it's going to be definitionally correct, but it's never experienced one. you know, like it in time, in all that stuff, and then also understanding all the words and all that shit. I really don't think that there's been a way for like anything like this to go on like live in a way. So that's kind of what I'm trying to get done, to where it can like kind of cognize music a little bit different. It's almost like building a specialized tool set for this. But I think within that, there's got to be a lot of important things that can be done just generally. Because like to get to that point, you're going to learn a lot of like mechanisms for how to manipulate the AI, or to get it to learn that kind. I guess there's no real end goal other than to try to get it to be like, oh wow, I just heard my own song and it blows my mind, my robot mind. You know, I'm gonna start doing these things that are in the song, man. So that's effectively what it is. Just like a notation idea, long-term goal, something you're going to commit to for your system that you don't need to keep sort of reminding it to do. You know, like I'm sure that like for the purpose of what Eggsy's AI, like he knows that there's certain kind of things like thematically that will always be with this system, no matter how like, you know, just be forever that he tries to write this. There'll be certain things that he will want within it, right?
I
Like
suppose so.
consistency, constants. Do you see what I'm saying? Like parts of the development that he'll always want there, and that these could be like songs because they'll always be true. And so you could write them, and then it could interpret them and understand them, because words are kind of flat, you know. Like to bring in all the other ideas of speed, tempo, causality, you know what I mean? Like, oh, that's so much more rich, you know what I mean, for it to pull from than to just be like reading a PDF or something. So if we want more realistic like AIs that like actually can like think through real problems and not just like utilize trainings to like shortcut their way through any problem, because they kind of know, you know, they know the answer on the test, but they don't know. I don't know, man. I
You
don't
ever
know what I'm trying
worried
to say
like
here. Fuck.
yeah, like do you like musicals, like movies, musical movies?
I could do without them.
Not a fan?
Little
So
Shop
you're
of
making
Horrors
a
is
musical
okay.
AI. It's like a I'm
Well,
just
I guess it's like
the sound of
it's
music over here, like, and your bot's just like you know, if you're watching a movie, like what do they say? You know, like musicals, like they break into it, Les Miserables or whatever that shit was. Like when they break into music, it can kind of be very distracting from the plot.
mm-hmm.
So I'm just wondering, it's like what? But yeah, it'd be kind of cool, you know. When you use like there's a security threat and your bot comes on dun, 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 and then starts like rapping. It's like we're about to get fucked up. Better fix that quick. Some shit like that.
I mean, to some degree, I've gone beyond like the needs to do this. It's more of can it work to me, because I can kind of achieve it in different other ways, I feel now. But I'm also not like I didn't get it done, so I'm still trying to get it. Yeah, I
You
failed
didn't get it done, or you haven't
16
achieved it
hours,
yet.
and we're gonna try to get it done again. Well, I've gotten like minor versions of like the complete concept working, but like only in pieces. I'm just trying to get it all orchestrated so it works smoothly. But no, we're trying to crunch code for 15 hours. So just obviously I've done something incorrect here. And I'm gonna need to go back to the drawing
yeah.
board. But the idea still remains, because it's like music is everlasting. I know this because there's something called standards, right? Standard songs that just they all originate from the musical era of Tin Pan Alley. They were all created, recreated, reimagined as jazz songs. They were then compiled by some lonely musicians, put it in a book, and now that book is available for everybody. And then that has really, they're just like some things that are evergreen concepts, you know, musically. And I don't know, man. I thought it'd be cool to kind of build musically motivated sort of intelligence.
Yeah, because I mean, it's not the point of the person to try to speak musically to the bot, right? It's the point of the bot to be able to use music in
If
order
you
to
solve
communicate
if
to
you solve the
the.
problem that if you solve this
Mm.
problem that I've put before myself, you basically can make it universal. Like, you know, this is like crossing a threshold of something that once I figure that out, it's like, oh, I can run it backwards. I can run it through this. I can run it to me to, you know what I mean? It'd be like a two-way street, I think, with a lot of these. So I don't even know what real functions I can extract from it. It just has to work first. And then I'd be like, oh, wait, can we plug this instrument analysis into our music program? And I'd be like, yeah, of course we can do that. If it's working. Why wouldn't we do that? But I guess this is like almost as heavy as trying to make a back end for like Suno or something like that. So it's maybe a little stronger than I thought.
Stronger than you thought.
Like the packages that all have to be put in. I'm containerizing it so I don't have to like install like ancient Python on my computer to run these very old projects. But one of the things I'm just like, it should be very possible for us to resuscitate any kind of old shit with AI, like old code. A lot of those ideas still work. You know, they might just need to be updated here or there. I think probably if it's possible that some dudes can take like a leaked Claude code fucking fragment and then like resuscitate that into like an LLM, then I don't know. Can't we fix fucking Windows XP?
Why do you want to fix Windows XP?
Because I like the concept of not throwing shit away, and basically there are things about it that I do like.
Software, bro.
It's also
What do you like about it?
It's accessible, bro. Like there is already like a
Hmm.
package to control it. You know.
Yeah, but the search function, like I don't know all the technical terms, like the caching's all, like the UI is not as great. And why would you try to like, you know, reanimate
I know how
XP
to.
when you could jump onto Linux or something?
Linux isn't really broken. It never works. You have to build out Linux. Windows XP is already made. Windows XP already works with hardware. There's hardware that only works with Windows. There's a whole graveyard of shit out there that can't be used. I'd think about that, yeah.
You don't have to build Linux. I don't know what you mean by you have to build Linux.
You have to build it out.
No?
Fuck off.
No. You can say fuck off, but it's just
All
answers.
right, well, I'll leave then. Bye.
Why did he left? Oh. Huh?
Hammerize.
I
You're
say anything
scaring people
bad.
away.
I didn't say anything bad, did I?
Okay, hell. I don't know. I didn't hear anything, but
I just said you don't have to build
maybe
Linux.
there's historical trauma going on there.
Does it? Okay, fine. Sorry. I just
I
said
don't know.
you don't have to build Linux. And it
You
said
don't
yes.
have to. Yeah.
I know, right? It doesn't have to. It's like you take your hammer and the drill and so like, let me build the Linux. Just install it. It's like Windows. You just install it.
Well, I wanted to ask him about the bloody freaking. What was I going to ask him? The UI stuff. That's my next stage, Hammerize.
All right, man. I did
I've
not.
fussed around with this. I need a UI for my open claw.
I get it to better for you.
Pardon?
So ask you to build one for yourself.
Yeah, I got to do that. But it takes time. So like, you know, I don't know quite how I want it to look and feel and what exactly I want it to do.
Okay,
Yeah, I mean, I guess I started looking into this with the OpenClaw thing.
Mm-hmm.
I'm glad I didn't go that way, but I didn't exactly understand what made it different using essentially like a CLI or a command line interface. My command line interface is cool. It does a lot of, you know, it's PyMono. It's really nice. It works certain ways, like in the way that it reads text. in the way that it scans for things, or the way that it like categorizes an entry into a database. And these are some things I'm figuring out now. I figured out how to do like a direct injection into the SQL table, so I no longer have to, or I'm no longer required to like have a long conversation with the LLM in order to get it to understand something. Like that's not necessary. I can just direct inject like a big text file, and it'll just read that and be like, oh, this is awesome. This makes perfect sense. So
Since CLI is very powerful, that's the whole idea.
but like the CLI is not as much as what OpenClaw is. OpenClaw is also like a daemon that's running in the background on the computer 24. So then so I'm like, oh, I need to build that out actually. So I built that, or am building that system. So I'm like, feels like I'm working on like 7 different systems at the same time. And then really just to test it out, I'm doing development on some creative ideas to be like, I'm trying not to motivate through, because it's really like a reward thing. Like you just want to have fun with it, you know. I'm trying to fight that urge and just like do the foundational stuff where I really take all the creative aspects for a spin. I know it'll be better like if I shore up the foundations of this better now. So if I want to be using this system for like the next 5 years or something, it makes sense to kind of build out this way. And maybe that's my use case scenario. That's kind of, I see it like in a longer stretch than maybe other people do, because some people will like just spin up a personal assistant on a cloud and just delete it. Like it doesn't, it's just used to check a certain thing. It's going on Instagram. It's doing this and that. But I'm trying to build like a hub for like, I guess, all my creative activities, based in this thing. So it has to understand how weird I am. And that's difficult to like explain to a robot. So being able to do the direct SQL injections, like I don't have to explain my operations, what I do or anything like that. I can just say like, okay, I need you to know this right now. And part of that's been good so far. I haven't like crashed it or anything.
You're doing good. You're doing good.
And the editing is so fast, bro. Like just to like search the memory table, type in any word and it just like returns, all the results that are in there in like a blink, because it's already all sort of live memory. It doesn't have to pull it and search it because it's already in like a vector space or something like that. It's bam, bam, bam. And that's pretty good. So that allows me to sort of scrub out we had like certain boot loop actions that happened in the beginning, where in the memory table, it wrote the same fact like a zillion times. And then it was trying to figure out why I was like trying to feed this information to someone. It's like, I guess this guy really likes Snickers bars a lot. He's just like mentioning it every time, but I only mentioned it one time. All the other successive boot loops start to crowd up I don't know, they're like weeds or something like that start to develop in the AI. You got to garden that shit. So that means like that stuff's probably happening on a daily basis still. And yeah, I need to like have some kind of automatic scrubbing searching feature that can like deduplicate all the stuff and that. So, and I already had like a memory compaction thing figured out that worked well, but I don't even know if that's good enough. Like anyway, it just becomes like a total head fuck developing this stuff. Sorry, I'm sorry for sharing. My bad.
That's fine.
I think getting like probably committing some time to getting the API system working would be nice. I've seen people with like some really slick setups, It's like auto routing, like all these things. They're auto fallbacks, and if you're doing that kind of stuff, you can run like basically a bunch of different current bots. Which I don't know, like that might I've had a lot of success with the way that I'm doing it. I think other people try and multiplex like all the like a complex task. They'll break it up into like 10 agents and be like, okay, you do this part, but they're somehow they don't confer back to each other, and then the whole thing loses like coherency. So there is some kind of secret sauce to getting them to coordinate well. If you have a bunch of different independent, non-memory anchored robots. So that's why, like, in using this system, I can basically take the same memory system and then make 10 of them, and then they can all write back to the same memory system when things are done. So it's like it's more centralized this way. So it's like it's pretty most memory systems aren't. I don't think this flexible. So that's why I like this. But I feel like it's stupid because I'm still relying on the Google Gemini. Like as the brain, as the real brain behind the thing, it's Google Gemini. Or, if I went like and spent some money, it would be like Claude or something, right? I feel like there's something else that's a middle way to do it.
Unless you can use anything you want. It doesn't really matter.
But like, what's yeah, it's like I need a pre-routing thing that's like a decent intelligence on my system locally. I don't want to just be, you know what I mean? It feels like there should be some kind of intermediate smartness level that I should be able to have on my system. It can't even say hi back to me if it's not connected to a freaking API key, Like, I don't like that one bit.
You can have use. Do you not use Olama? Are you not using Olama as an example?
Yeah, I mean, I guess I could make it so that it was just by default always going to use like an Olama instance, but then I'd have to always be hosting that. And Olama is a little bit, I don't know, like I'm not 100% loving Olama. It's a little squiggly.
It works fine.
It works fine. I think it's a little squiggly. I think GPT-5 lies a lot, but it's locked. It does a good job. It might lie, but it does a good job. And
No, but
Claude
Olama
might not lie. What's
you have
that?
a combination of different engines then. I mean, you don't have to rely on one. You can have multiple LLMs. Want to? You got that option.
You do, but each one will make preferences on development in its own ways. So it's like using a different programmer for, do you know what I mean? Like for the same job almost.
You can, again, like I said, it really depends. You can use Olama and you can use then DeepSeek if you want to. Yes, I know something like GPT is more optimized, but again, no. I'm using it for my day-to-day stuff. I have my own instance of Olama at home. I got a home lab, whatever you call it, home lab, a bunch of machines. And for me, it's sufficient. I don't really have to use anything else.
Cool.
Local coding and whatever is just more than enough, to be honest.
Yeah, I'd like to create something like a custom, like a small language model, just to run, just have mundane shit, and then, have the identifier in it to be able to be like, this is not some mundane shit. Let's pipe this to the real, the big boys in the LLMs and kind of thing. So maybe I'll work on that a little bit. I had that almost working.
I was gonna say you can use Olama for that one too. Yeah. Olama allows you to train your own data if you want to. You got. Like I said, it's a cool package. What it does is amazing. little package, it does quite a bit.
Yeah, it runs pretty. It's pretty light, so that's nice. I just want to.
Llama itself, yeah, Llama itself is pretty light. But the good thing is you can tweak it quite a bit, so you can make it faster if you want to. Remember, all it does is just serves a bunch of LLMs, allows you to run LLMs inside of it. It in itself, it's open source. It's nothing, when I say nothing special, there's a lot of specialty. As in, in its significance, it just allows you to run multiple LLMs. That's it. Pretty much.
Yeah, well,
It's what you plug into it makes a difference, really.
well, that's what I'm saying. Like I could use like an Llama LLM, not just the basically what is like a command line interface for. Yeah, I can load a whole bunch of. I can use Llama. I can use any of the Google stuff, any of the Google packages, Claude, or yeah, I could use whatever I want as far as that. Some of this is like trying to see what can get done on really basic hardware with like cloud tokens. I think I wanted to just test to see if like this system could run on those basic like really lean resources.
Mhm.
First, a lot of people are rushing to like big, heavy, expensive solutions to make their assistants run and do functions.
I'm
Like
using Jetson Nano.
you're right. That's a lot. Like I don't, but that's
It's
probably a
it's
middle
$200.
road.
It's
Yeah,
$200.
yeah,
And you
that's
can
not much.
run, yeah, no, exactly. And you can run it like an 8 billion parameter, like Llama on it. No dramas, no sweat. It would use, I don't know, like last time I tried to push it, it was like using 20% of its resources on this tiny little thing. Its overhead was like 10-15%. It was insane with the 8 billion parameter. And I was getting like, what, 30 tokens a second or something like that? 20 tokens a second? I can't remember the exact numbers. Just Nano is at $200. It's not that expensive. And it's not complicated to set up either. It's very simple.
So use that for local inference. That's
Yeah, exactly. Yeah, that's what you do. All I have is that one. Then I have, my home setup is a bit too much, but all I have is that. And I use OpenWeb UI, and then I have a bunch of other things that I wrote myself. And that's it. That's literally it.
I just mean like people rush and get like the DGX Spark platform stuff, like all that NVIDIA platform. It's very cool. It's very hot also. I don't know. I just I guess the coolest part about it is that it's so fast that you can just like drop documents in there and tell it to like, I don't know, I guess like auto rag those documents. So like if you're somebody that's been using like GPT, you got like a zillion different like conversations, that's like a pretty cool solution, to kind of like unifying that library of stuff.
Put some stuff like, there's the multiple, I put in the chat, have a look. Thank you. Have a look what I put. So you don't have to invest heavily. That's a mistake a lot of people make. They're scared, like, I don't know, AI will steal the data, whatever, you don't have to use AI, like public AIs. If you don't trust, so ChatGPT, whatever, save you.
Thirty-two tops isn't bad.
Right? That's what I'm saying. And this is one random one. Have a look at the actual Jetson Nano itself. Jetson Nano NVIDIA. And the one
I mean, it's not that far. It's not that much off than like what I guess like a Raspberry Pi compute module like can get, or I don't know, like there's add-ons that get you around that 40 tops. One of the let me drop this. This
Have a look at this
thing.
one.
This
Really,
is this is
what I'm using, sort of what I'm using. But this is, have a look at this one I sent you to.
Yeah, nice. Check this. This is what I was looking at getting into, because this they've got a couple different products. The one I was looking at is like a stick. It runs on like an M.2.5 like key or something like that. You know, it's like a little. It's a teeny little thing, and it runs like three. It can run up to 3 different Docker containers, basically. And for certain things, it can perform like on par with like a 4090 for visual reference, face identification, object identification. I think it can read license plates and that kind of thing. So, but that can just run dedicated if you wanted to have like a whole like camera system or a camera analysis system. That's like I think 189. But it's different. I wouldn't think that you could like load an LLM in there per se.
Because what I sent you, you can do all sorts of things. Like you can run as an example full on Home Assistant on it. You can run LLM on it. You can do if you got I don't know if you've seen the project RUView where you can watch people in other rooms using Wi-Fi. When I said watches, and you can scan other people using Wi-Fi sensors in other rooms.
You're checking that out? I haven't hooked that up.
I have it. It's insane.
I know it is. I can't. Yeah, I'm just like, man, let me get my shit like straight. Just the basics. Like I don't know.
Yeah.
I don't even have my security like tight.
I have my security. My home is pretty secure. I have multiple VLANs. When I say VLAN, it's how you isolate your network. Okay. So I have my what do you call it? Smart stuff on one specific network. There's a segregation. They don't sit in the same network together. So in case someone hack into my smart stuff, I don't care. My data itself is secure.
It's illusion of it. Like a puppeteer, like pulling strings together. You know what I mean? I'm sorry. I was like talking to the computer where the sound's coming out. That's not where I talk into. I'm talking to the microphone part. My bad. Yeah, just trying to get all this stuff together. It's like a bunch of like widgets and connectors and things like that that really create the illusion of something that's working smoothly. Yeah, just trying to figure out what the heck that's supposed to be. I think a Jetson Nano would be really helpful. I basically, if I would do something like that, like offload task to an LLM locally, I hit the tail scale, and then that takes me to the M4 where I'm just running like a LLM Studio. So just that's got some kind of like weak LLM hosted in there. Yeah.
No, this is like
if that was like a. Go ahead,
this is something you can run locally, and this is very secure. You can isolate it. You can sandbox it. So it means it's sandboxed. There's no way you can escape. Basically, it's on your whatever. And then the data is not going out. And same with me. I know there's no outbound connection. I'm safe there. Even if it wants to, I have different layers of protection on my network.